Now, toxicology is the study of chemical hazards. Even though, the human health in the world are improving as in general because of the wealth of the advanced technology, our modern society is exposing us to more and more man-made chemicals. And some of these substances, they actually pose threat to us, our human health. But to figure out which of them do and how, to how much is a really, very convoluted issue. The very famous Swiss alchemist Paracelsus says, "All things are poisons, for there is nothing without poisonous qualities. It is only the dose which makes a thing poison." So toxicology is a science that examines the effects of poisonous substances in human and other organisms. And the toxicologists are the people, who assess and compare the substances to determine the toxicity. By what? It's more than the dose, okay? Sometimes dose is certainly a factor. Like even sugar, too much of sugar is bad for the body because of kind of addiction. And the degree of harm a chemical substance that can inflict. So this is like the toxicity. Like what Paracelsus says, right? The dose is like a poison. So in his words, he's saying that a substance toxicity depends not only on its chemical property, but also on its quantity. Now, these are the many areas that toxicology covers. So it ranges from biology, pharmacology, medicine, pathology, you name it, engineering, stats, and we are now zooming in on the chemistry part. Now, in recent decades, right, we have a growing amount of production of chemicals, especially man-made ones. So the amount of the chemical contaminants in the air and environment has grown, and it causes more public concern. How do we contain it? So given the rise to the environmental toxicology, so we need to give more care to feedback to the agency, how we are safely protected from these potentially harmful substances. So this is a mind map there. NTOX, short stands for environmental toxicology. You can divide it into many disciplinary core, and subcategories there. And they are not exhaustive. So it's good to know some of them, but you don't have to memorize them. You can also link to what we study in this topic. In this module CM3261, you have got some soil, some risk assessment, response. We also do environmental chemistry here, right? So the toxicologists, they generally focus on human health and using other organisms as models and the test subjects. These toxicologists, right, they study animals and plants to determine the ecological impact of the toxic substances and see whether the other organisms, like the birds in the coal mine, they can serve as a predictor of the health threats that can affect people. Now you got to know that there are two main kinds of approach to environmental toxicology. One is the retrospective approach, which is to assess the amount of toxicity in the environment and use it to determine the potential past, present, and future impact, like cancer study. There's also a prospective approach, means you're forward predictive. Based on the evidence in the past, you need to try to gauge the future, how it's going to be like. So one of the examples is your QSAR model, stands for Quantitative Structural Activity Relationship. You need to look at SAR if you're doing organic chemistry to make a new drug in the pharmaceutical sector. So, and we use it, derive it from a computational model. So from what you can tell, retrospectively, you're looking back and trying to draw a link, drawing connections, but that gives you some kind of biases, You may think there's a causation, but actually just be a correlation. So a toxicant is any chemical that's natural or synthetic, man-made origin, and is capable of causing harmful effects on a living organism. So some of the sources of environmental toxicants, we've got point source, right? That point source means they are discrete discharge of chemicals coming from identifiable places. So for instance, we can have this industrial dump, smoke tags, and other stationary atmospheric discharge, like a factory that's burning incense, or the incineration plant. We also have the non-point sources, and they are more diffuse, more widespread, so not so concentrated. So perhaps you have a farmland, a farm, that's so big, 50,000 hectares there, then you do not know, which is exactly site to have the toxicant being released. Traffic also, you have got many cars and maybe you have got air pollution, but you see, you got so many roads, streets, we do not know where it comes from. So it spreads over a large area. So I've given you some selected environmental toxicants here, categorized by outdoor air, food, water, indoors, and I will elaborate on some of them. So I'd like to focus on the radon here, radon and cigarette smoke. They're the top causes of lung cancer in the developed nations. And the radon is a very highly toxic radioactive gas that is colorless, undetectable without specialized kit, odorless. We may be breathing this right now. So what's so harmful about radon? So it seeps up from the underground areas or a certain kind of bedrock system, and it also accumulates in the basement and the homes with very poor circulation system. Maybe in Singapore, if we all stay in a HDB or condominium, right, with high-rise buildings is fine, but if you stay in landed property, you might be a bit more exposed to radon. Another indoor hazard is called asbestos. I believe most of you have heard about it. So there are several types of asbestos. But each of them are just minerals that form very long and thin microscopic long fiber, and its structure, because it's so fibrous, right, with many cavities between them, they are able to trap heat because air is a very poor conductor of heat. Now the thing is, this small fiber, right, they trap heat means for trap air. Trap air means you trap oxygen, means they are super flammable. Since they trap air, trap heat, they are used to what? To insulate buildings to keep ourselves warm, right? And also when we have aircon, we also do not want to lose so much of the cool air. But it makes it very dangerous also when we inhale, not only because it's flammable. So when we inhale it, right, it's a so fine fiber, they get stuck to the lungs. And it irritates our lungs. And what does the lungs do? As a body natural system, it will release some acid, right, to try to digest it. But we know that this acid coming from our human lung, it cannot even do anything, but the response is okay to have some liquid to absorb it, to kill it, but it doesn't disintegrate. In fact, this acid, right, they have a very low pH, they even burn the linings. They cause scars. And when it causes scars, you are killing off the cells there, but yet the asbestos stay there. So it's like a double whammy here. So because of this, many countries, Singapore, Australia has banned it for years. But there are countries like in China, they might still be using some of them in the cars or the buildings, but we can't safely say that. So people say, oh, since it's so bad, right, let's dispose it. But what happens is, if we dispose or destroy a building that uses this asbestos, what happens? We're releasing to the air. That means people are just breathing it again. So the best way to cordon off a building that uses asbestos is to block it off, to contain it, to wrap it, and don't touch it. Here, we also talk about lead. Indoor are more closely relevant to us. Okay, so lead poisoning is another indoor hazard, and we know that when we ingest lead, this is a heavy metal, very high MR 208, causes damage to our brain, liver, kidney, stomach. Because once it can attach to the proteins, it's more biochemistry here. It will change the conformation of the protein structure that it can't function. The quaternary structure and tertiary structure get dislodged, so it can't act as the good active site. So besides that, we have learning problems and behavioral abnormalities, anemia, hearing losses, even death. Now in Indonesia, where the petrol, they still contain lead, it's not unleaded petrol. So it has been found that the children who live along the roads, right, their parents are working as hawkers there, they are more exposed to this lead. And it's tested that their brain contains a bit more lead, and their IQs on the lower side, they don't do well in schools, and it just cascades down to the life. A bit sad. So we are very thankful that in Singapore, leaded petrols has been banned for many years.